My apologies. What is this? Stop. Okay, start over. Good morning. Welcome back. This is Geography 10, Lecture 5. I have a cold. Today we start the section of the course in which we step back as far as we're going to step, temporally speaking. So we're going to our largest temporal scale. A week from today, I'll be in Denver, and you will watch a movie in lecture about favelas, slums in Rio. So that will sort of be we're a little out of step here, as I think I explained previously. For today, the reading was Crosby, the first two chapters. You should skip chapter 3, or you may skip chapter 3. Read chapters 4 and 5 for Thursday. A week from today, we will see the movie, or you will see the movie. Thursday after that, I'd like you to be sure by that point to have read pages 16 to 31 in the Atlas. Any questions about that? Yesterday we sat down and compared notes, compared the list of people in the class to the list of people coming to sections, and it turned out that there was nobody who had stopped coming to section or failed to come to section yet and had failed to drop the class. So we did not have to drop anyone. The wait list has now shrunk to about 22. I don't know what it might be. That was as of yesterday. I don't know what it might be as of this moment. In many ways now, it's just a question of how many people drop. So if you're on the wait list, all I can say is keep an eye on the wait list, see if it continues to shrink as it has. As I said before in previous years, everyone who's wanted to get into the class has eventually gotten into the class. But I realize at this point that it's kind of hard to know what to do if you're on the wait list. I realize that's not really a satisfactory answer, but are there any questions about that? Any housekeeping matters? Okay, good. So, what is this book, this ecological imperialism book, about? Crosby is interested in explaining or looking at what he calls the Neo-Europes. And these are places he defines as places where descendants of Europeans have come to dominate since 1492. The previous instructor brought it back just before I started. Okay, thanks. Come to dominate since 1492, that is, since Columbus sailed across the Atlantic Ocean and discovered the New World, despite being far from Europe itself. And this does not include every place where Europeans established political control. He's talking about come to dominate demographically, come to actually be the preponderant peoples of those places, right? This includes North America, especially in the eastern part, and by this, what is he referring to if we were to say that the eastern part of North America is more dominated by European descendants than the western part? Yeah. Okay, we might look at the current demographic makeup of the United States and recognize that there is a large number of immigrants from Latin America in the population of the western U.S. now.
Traditionally, European immigrants come to the eastern United States first.
Okay, they got there first. That's true. Yeah. Okay, although the Spanish are Europeans too, right?
Yeah.
Okay, yeah. The East Coast is more densely populated than the western half of the United States. And there are fairly significant places in the western half of North America that are still tribal, right? Lands that are sovereign lands of tribes. It's not that there are huge numbers of indigenous Native Americans dominating those areas. But relative to the eastern half of the United States, significant parts of the western U.S. still are inhabited by and held by native peoples. That's true in Canada as well as in the United States. I think it's the density issue, and I think it's it's a relative question. It's a question of to what degree have European descendants dominated both demographically and geographically in terms of just the land possession of land. Okay? It also includes southern South America. Have any of you been to Buenos Aires, Argentina, for example? What do you see when you get off the plane in Argentina? I mean, what do the people look like? Yeah. They look like white people. Yeah, how about that? That's what he's talking about. And it may be news to some of you that southern South America is actually, you get off the plane, it looks like you're getting off the plane somewhere in the United States or somewhere in Europe. Eastern Australia and New Zealand are also Neo-Europes by Crosby's definition. Any questions about that? So he observes, he notices that something is interesting about these places. They all produce prodigious amounts of food, well in excess of the needs of the people who live there. They produce surpluses, huge surpluses of food. And this is the food supply on which much of the rest of the world depends via trade. So, a long time ago, Europeans spread out across the world, and certain parts of the world they came to dominate disproportionately. And those places today are places where enormous amounts of surplus food are produced, which are then traded with other parts of the world, which depend on those surpluses for a significant amount of their food supply. And Crosby simply wants to ask, why? How did this come to be? Why should this be the distribution, the pattern of peoples and food, or peoples understood in a kind of demographic and ethnic sense, and food production at a global scale? And this is where we suddenly find him stepping back enormous, enormous lengths of time. Everyone know what this is? Anybody want to vote on how we'll pronounce it this semester? Shall we say Pangea? Does that work for you? All right. It doesn't look like that's how you'd pronounce it, but that's how we're going to pronounce it. Okay? I honestly am not sure exactly how it's supposed to be pronounced. But that's how you spell it, and we're going to say Pangea. What is it? It's up there in the upper left. It's written across that landmass. Everyone knows what Pangea was? Yes? No? Shall we talk about it? Everyone know why it doesn't exist anymore? Yes? No? I'm getting like no response from you guys. Yes? Okay, good. So, upper left-hand corner is what the land masses of the world looked like, or rather how they were distributed 225 million years ago in the Permian age, or epoch. At that point in time, basically there was one landmass on Earth. All the continents were stuck together, or rather they hadn't come apart yet. What difference does that make? What does that mean? We're talking about evolution here, divergent evolution. For example, mammals diversified more in a shorter period of time than reptiles had. Anyone want to explain why that caption is situated next to these pictures? Yeah?
Because reptiles dominated when Pangea was a whole, and so they had one continent over
Okay. Bingo. Everyone heard that, right? At the time of the Permian, when Pangea existed, the dominant form of animal life on Earth was reptiles. Everyone's heard of the dinosaurs, right? The fact that they all existed on one landmass was important for the evolutionary processes, or the what happened as dinosaurs evolved. The reason it's important is that they were all evolving in potential competition with each other. They could all intermix with each other over land. And that meant that as they bred, mutated, evolved, there was only one sort of stage on which they were evolving. Then slowly the continents started to split apart. And you see in the Triassic, they had begun to separate. There was Laurasia and Gondwana land, sort of two predominant land masses. In the Jurassic period, they begun to split further. By the time we get to the Cretaceous, 65 million years ago, you actually can see the continents that we're familiar with today. And they are separated by large bodies of water. And then you get down to the present day, and you can see that Africa and Asia are separated by significant bodies of water from the Americas and from Australia. By this point in time, it's mammals rather than reptiles that dominate, correct? Thank you. And at this point in time, because the land masses are separated, each continent or supercontinent is a separate stage for purposes of evolution, right? The animals there can breed, mutate, evolve, compete with each other without interacting with the animals on another continent, separated by thousands of miles of water. As a result, you get a greater diversity, taking it at the world scale, because each of those continents can sort of give rise to its own evolutionary trajectories and results. And it's interesting. I mean, what that means from an evolutionary point of view is just that there's a great deal more diversity among mammals, given the amount of time that they have dominated the Earth, than there was among reptiles, given the amount of time that they dominated the Earth. So, temporal process of tectonic drift, right? That's the name given to the movement of the continents, which split up Pangea and created the continents we're familiar with today. Very slow, long-term process, which affects another process, evolution, and creates patterns at, in this case, the scale of continents, which, if aggregated for the world as a whole, create a pattern of greater diversity. Any questions? Here we have some of that mammal diversity. Anyone want to venture a guess where these animals are, or rather were? Where is this picture set? What's it look like to you? Africa. Wrong. Asia. Wrong. North America. Yeehaw. Check it out. Lions and mammoths. Crazy. Yes, these were here. Some of the finest fossil remains of them are found down in Southern California, right? In the La Brea tar pits. There's magnificent collections of, or deposits, I should say, of the fossils of some of these creatures. Now, we're still not even close to getting back to exactly why this matters, but you have to just bear with us. We're slowly going to make our way towards Crosby's point. Thinking again at evolutionary timescales and geological timescales. I still haven't replaced my battery, so my pointer is still not working. The line that's going up and down and up and down and up and down is sea level relative to the present. Okay? And this is going back. The present is way over here at the left. And by the time you get to the far right, you're at 2.6 million years ago. The Pleistocene, this is mostly the Pleistocene epoch, which is to say that just before the one that we consider ourselves to be in now, the Holocene. The Pleistocene lasts roughly 2 million years, so it takes up virtually all of this. And the Holocene is just the last 10,000 years. You barely see it. It's right at the end there. Homo sapiens emerged about 40,000 years ago. So humanity in our current form, from an evolutionary perspective, is also just a very little, teeny little bit at the end of this graph. Why does this matter? So the thing to observe right away is that sea level has gone up and down and up and down and up and down and up and down over the duration of the Pleistocene. And then hold on to these last two dates. 40,000 years ago, humans in our modern form emerge. 10,000 years ago, we enter the Holocene, which is the period of time that we're mostly going to focus on when we're talking about Crosby and sort of how he sets his argument up. What difference does it make that sea level has gone up and down? Well, first of all, why has sea level gone up and down and up and down and up and down and up and down? Yeah. Because of the ice ages. Everyone understands that, right? During an ice age, vast quantities of water end up on land in the form of ice, and that water has to come from somewhere. And ultimately, where it comes from is the oceans. And as a result, if you have enough ice on land, you have less water in the oceans, and the level of the oceans falls. When the ice melts, it all ends up back in the oceans, and the level of the oceans goes up. That sounds, well, that is basically pretty simple. Yeah?
So every time the graph dips, there was an ice age or melting?
Bingo. Every time the graph dips, it was an ice age. It's one of the magnificent, crazy, interesting patterns of Earth history over the last 2 million years is that it went in and out and in and out and in and out and in and out of ice ages. Are we in an ice age now? No, we're not. We're not in an ice age. The Holocene is what's called an interglacial, a period of time that we're now about 10 to 20,000 years into, closer to 20,000 years into, in between ice ages. And typically these interglacials have lasted about 20,000 years. And then the world has gone back into an ice age. And that ice age has typically lasted, what? Somewhere between 80 and 120,000 years. So the Earth spends a lot more time in ice age, or has spent a lot more time in ice ages in the last 2 million years than it has spent being all nice and warm like it is now. Funny little curiosity, about 25, 30 years ago, even as scientists were beginning to consolidate their awareness and understanding of global warming, the fear among a lot of Earth scientists was actually that we were just coming to the end of our interglacial and it was going to start getting really cold and we were going to have another ice age. And they went so far as to write a letter to President Nixon and say, buddy, you really got to take this seriously, man. We might be at the end of our interglacial. We got to worry about global cooling. Well, we've fixed that problem, haven't we? Okay. So, what difference does this make? Northern Hemisphere ice coverage 18,000 years before the present. So this is just before the end of the last ice age, or at the end of the last ice age. And you can see, man, I need my pointer today, don't I? Something fierce. You can see that basically the upper half of North America is under ice. The ice extends all the way down across Iowa into the Midwest. Chicago, New York were under a couple of miles of ice. Today, it's just that little Greenland thing that's under a comparable kind of ice sheet, right? And the Arctic Ocean pictured here is, you know, I guess it's frozen over, although we're having a hard time keeping it frozen these days. It's depicted here. You can see it's, yeah, the ice is sticking well down across the Great Lakes. What does this mean? What difference does this make? Well, here are a couple of maps. Well, let's start in the upper left. What's that? Where is that? That's the southeastern United States. The green, the dark green, depicts what we think of today as Florida, right? The lighter green is what Florida would look like if the ocean were 35 meters higher than it is now, which is to say where it was in the Pliocene 3 million years ago, the Pliocene being the last time the Earth as a whole, climatically speaking, was warmer than it is now. Oops. I mean, seriously. 3.5 million years ago is how far you have to go back to find a period of time in which the Earth was warmer by any significant amount than it is today, which is creepy to think about. The light blue is what the coastline of the southeastern part of North America would look like if the ocean were 120 meters shallower than it is now, which is to say where it was at that point 18,000 years ago during the last ice age. So there was enough water tied up on land in those ice sheets to lower the oceans of the world 120 meters and make the coastline of North America look significantly different from what it looks now. If you look at it from the perspective of all of North America, what this means is that there was land connecting North America, or Alaska, what we think of as Alaska today, with Asia, Siberia. This is the famous Bering Land Bridge. And it was, part of it was probably covered in ice. Perhaps much of it was covered in ice. But it was not ocean. It was land. And what this means is that it was possible, if you could withstand the horribly cold weather, to walk from Asia into North America. Or perhaps, if you had some kind of boat, to sort of skirt along the coastline and make your way to North America. That is, if you were a human with a boat. Where is this? And it's not the Field Museum. This is Southeast Asia and Australia. Here again, the lighter green depicts what the land, what the coastlines, what the terrestrial area would have been during a period of much lower sea levels. The slightly darker green is what it is now in an interglacial with higher sea levels. So what today is a series of islands, an archipelago with significant expanses of water between mainland Southeast Asia, Indonesia, and Australia at the end of the last ice age was largely land. There were some gaps where it was ocean, but they were much, much smaller than they are now. Any questions? Yeah.
Why would anybody walk across a huge frozen landmass if they don't know what's on the other side?
Why would anybody walk across a huge frozen landmass if they don't know what's on the other side? That's a really good question, but I suspect there's basically no way to answer it. I mean, we can speculate. We can offer theories. Another way of thinking about it would just be, you could, it would be romantic to think that it's sort of, why do people climb mountains? That kind of thing. It would be perhaps, other people might want to say, no, it's not about that. It's about the fact that, living beings occupy habitat that they can occupy, right? Humans can occupy a wide variety of habitats, particularly once we develop certain tools and technologies. And why wouldn't we go ahead and occupy whatever we could? Yeah.
Probably say something about how there was overpopulation, like there started to be a lot of people.
Okay. We could speculate that there was some kind of need to move because there weren't enough resources in the places where humans were to support the populations of humans as they grew, and therefore they were sort of impelled to migrate, to disperse outwards, and they kept dispersing, and eventually they got to the Bering Land Bridge, and they just kept going, right? I would be a little leery of calling it overpopulation, just because that implies some kind of really direct relationship, when it's very difficult to know whether that, in fact, that relationship is nearly that direct. But yes, dispersal and migration is one way of, and that's actually very similar to what I was saying a moment ago about, well, we're going to spread to whatever habitat we can, right? Yeah.
I thought there was a theory that a bunch of tribes in northern Siberia came across the strait because they're nomadic and they're following the
Okay. It's possible that this, yes, these were hunter-gatherers, right? This is way before domestication of plants and animals. So these were humans subsisting on whatever they could catch, kill, dig up, harvest, right? From wild plants and animals and fish. And it's possible that a group of people chasing a group of animals happened to chase them right across the Bering Land Bridge. The speculation is that there were actually gaps in the ice sheet that permitted, nobody's saying that these humans actually walked across 1,500 miles of ice sheet, a mile or two thick, right? No one's talking about that. We're talking about a moment in time, granted, could have been a couple thousand years, but it's a moment in time, geologically speaking, during which it's sort of hypothesized there was either some kind of path through the ice such that these humans could have access to things like plants and animals, or that, in fact, it was a migration along the coast rather than through the middle of the continent. And they made their way through and made it to the Great Plains and continued south, all the way to the tip of South America. This was the peopling of the Americas by humans. And there's also a point in time identifiable at which point humans spread into Australia. And the key point here is that the pattern of ice ages and sea level rise and fall created windows in time when these migrations could occur. we'll talk about what happened once people arrived in places like the Americas and Australia in a moment. And maybe actually not till next time, but we will talk about that. That's part of this story. The implications of the arrival of people in these places. But first, we're going to talk about the Neolithic Revolution, which is what precedes it. The Paleolithic. What does lithic refer to? Rock. We're talking about a period of time when rocks provided the raw material for tools for humans. We were working with stones. This is the Stone Age. The Neolithic is the newer part of the new and improved Stone Age. When we go from grinding and polishing stone tools to smelting metal, we actually discover, invent, come to control metal, which of course is derived from stones or from rock, but nonetheless is a huge technological advance in terms of what it enables us to do, the kinds of tools it enables us to manufacture, and the things we can do with those tools. And it happens that some of the things we did at about the same time or subsequent to this discovery were inventing agriculture, domesticating plants and animals, coming up with writing, and building cities. So it's kind of a big deal, this Neolithic thing, right? This really sets us on a new course in terms of virtually everything. What we can do, what we do, how we make things, how we interact with each other, the kinds of, writing is a pretty big deal in terms of how it changes the way you can distribute, disseminate, teach, take care of, pass on knowledge and information, right? It affects how you can control people, how you can organize people, organize stuff. Agriculture gives us this power of producing food on vastly larger scales than was available to us when we were simply hunting and gathering. So this is a key moment. It occurs at different times and with different plants and animals on different continents. So you might say this is another example of divergent evolution, although that would be stretching it, right? Because, in fact, we're talking about the same species. We're not talking about different species of humans. We're talking about humans in all cases. So this isn't really evolution in the Darwinian sense. But we are able to identify that this set of transformations occurred in different places at different times. The key point for Crosby is that it occurs first in what we now think of as the Middle East. The Neolithic Revolution, according to Crosby, he says, at its base is a matter of the direct control and exploitation of many species for the sake of one. So he's looking at this ecologically. He's sort of asking, what are the ecological circumstances surrounding or consequences of the Neolithic Revolution? And he's going to zero in on agriculture, the domestication of plants and animals. And he's suggesting this is when humans, as one species, come to control and exploit other species of plants and animals for their own benefit. The most important contrast, and here we're talking about between the continents, between the Neolithic revolutions on different continents, involves the matter of livestock. And I will come back to that in a subsequent lecture, but I wanted to underscore that point right now. To the extent that he gives us any single variable to look at, it's livestock. Might sound a little peculiar, but that's what he says. All right, 5-minute break. Okay. So we may not make it through all the slides today, but that's all right. We can pick it up again on Thursday. Here, we might pick this as a nice, concise statement of Crosby's thesis. So remember, we started with the question, why the Neo-Europes exist today. This combination of descendants of Europeans far from Europe and food production, surplus food production. Why is it distributed the way it is today? And to the extent that there's one sentence that captures his explanation, his answer, it's this. The triumph of the European invaders in the Americas and Australasia owed as much or more to the Old World Neolithic Revolution as to the developments in Europe between the age when Abraham tended his sheep in the Fertile Crescent and when Columbus, Magellan, and Cook crossed the seams of Pangaea. That's all, flowery, articulate, perhaps, eloquent language, a fancy way of saying, in his opinion, or his thesis is, the reason the Neo-Europes exist today, where they do, has more to do with what happened in Eurasia during the Old World Neolithic Revolution, has more to do with what happened up to that point when agriculture developed and writing developed and cities developed in what's now southwestern Asia, than it has to do with everything that happened since then, between then and Columbus, 1492. So he's saying the explanation lies basically about 8,000 to 10,000 years ago, when a variety of things happened having to do with domesticating plants and animals, than it does with anything that's happened since then. Does that sound plausible to you on the face of it? So this is not about, the rise of Roman civilization. This is not about the Italian city-states. This is not about the kings who paid for Columbus's expedition. This is about stuff that happened before the Roman Empire even existed. Does that sound plausible to you? Yes, no, maybe? It's supposed to sound at least implausible enough to be interesting. Okay? All right. Plants, germs, and animals. Yes, I intend this as something of a pun on guns, germs, and steel. Okay? And I think I mentioned to you that the first couple years I taught this course, we read Guns, Germs, and Steel. And eventually, I stopped teaching it and replaced it with ecological imperialism for a number of reasons. But the main reason is Alfred Crosby deserves the credit. This book came way before Guns, Germs, and Steel. And something on the order, I would put it at like 85% of what Jared Diamond has to say in Guns, Germs, and Steel, Alfred Crosby said first. And he not only said it first, he said it better. He may not be quite as good a writer as Jared Diamond, but he is a better thinker. At least he deserves the credit for most of what we might call original in Jared Diamond's book. And I do not mean any disrespect to Jared Diamond. I simply mean Alfred Crosby deserves the credit. So here it is. These are the things that he is going to highlight and unpack for us, the components of his explanation to support his thesis. Food crops, such as wheat, were part of this Old World Neolithic Revolution. Domesticated livestock, such as cattle, horses, sheep, goats, and pigs, are part of this Old World Neolithic revolution. Diseases such as smallpox and measles. Weeds that were adapted to high degrees of disturbance, such as plowing and cropping. What's a weed? Anything that a farmer doesn't want. That's pretty close. Actually, I was going to say a weed is a plant out of place. A weed is any plant that we don't like what it's doing, where it's doing it. There is no other definition of a weed. Well, or rather, any other definition of a weed is as arbitrary as that one, right? But it's also the case, generally speaking, that most of what we call weeds are plants that grow quickly in disturbed soil. Hence, farmers' antipathy towards them, right? You plow the soil to plant a crop, and lo and behold, these other things grow as well. And they're annoying, therefore we call them weeds. Vermin, such as rats, can be linked, traced from an evolutionary point of view. Rather, the roles that they play ecologically are intimately related to these other developments. Farming and storing food, for example. And finally, immune systems resistant to crowd diseases. These are the ecological components of this Old World Neolithic revolution. And Crosby's going to show us, explain for us, why, how these things which emerged in Southwest Asia and spread to Europe, when they migrated after 1492 to places like North and South America, they were what made the Neo-Europeans flourish and prosper and dominate, and essentially eliminate the humans, the native humans, not completely, but to an extraordinary degree, such that you ended up with a population that's basically all European descendants. And we'll get into, there are all kinds of other wrinkles to this. I mean, it sounds, I'm oversimplifying it for now, but and we'll get into those ways in which this is not quite that simple. But that's the basic gist of this argument. And our job is to understand the details. What were these processes? How did this happen? And we're going to talk in some detail about what Crosby calls the portmanteau biota. He says the Europeans brought with them fellow life forms, their extended family of plants, animals, and micro-life. Descendants, most of them, of organisms that humans had first domesticated or that had first adapted to living with humans in the hearthlands of Old World civilization. This portmanteau biota was crucial to their successes in the Canary, Azores, and Madeira Islands, and to their successes and failures later and elsewhere. Where it worked, where enough of its members prospered and propagated to create versions of Europe, however incomplete and distorted, Europeans themselves prospered and propagated. So we have to think about our plants, our animals, our diseases, our weeds, our vermin. We all came as a package, so to speak, across the Atlantic Ocean or across other oceans and landed in various different places. And in some places, that team prospered and established itself and was sort of fit nicely. In other places, it didn't work so well. And he's suggesting in places where it worked, the Neo-Europes developed. Where it didn't work, they didn't. Does that make sense? Is that clear enough? So, we might sum this up as Europeans and their biota functioned as an ecological team. Their germs annihilated populations that lacked immune resistance. When the Europeans showed up in the Americas, something on the order of 90% of the native populations died of diseases that we brought with us, that Europeans brought with them. Diseases like smallpox. Just massive, massive. It's not decimation. Decimation will be 1 in 10. This is 9 in 10 died, roughly. Their livestock and plows laid low the native vegetation. Their weeds and vermin thrived in the niches opened up as the native vegetation was altered, either by plowing or by grazing. The team worked best in climatic conditions similar to those found in Europe. So if you look at southern South America, you look at southeastern Australia, you find climates, and you look at most of the United States, you find climates that were similar in broad strokes to the climates of Europe, where these organisms, this portmanteau biota, had come from. And that would appear to be some kind of explanation, right? Or it suggests itself. Now, this begins to look like a kind of Malthusian argument, or you could sort of map a Malthusian argument onto it. You could say, okay, the Old World Neolithic Revolution produced innovations in food production that led to population growth in Europe. I mean, someone asked, why would you walk across the Bering Land Bridge? Well, why would you get on a boat and sail across the Atlantic Ocean if you don't know if the ocean ever ends, right? Well, just as you might speculate some kind of overpopulation or some kind of push factor behind the movement of humans across the Bering Land Bridge, you might also speculate a push factor driving people out from Europe in 1492. You might say, okay, this leads to crowd diseases in Europe. We're going to talk about what a crowd disease is later, but for now let's just use the bubonic plague as an example, which results in misery and death in Europe. 14th century plagues killed roughly 1/3 of the population in Europe. So you might say, okay, this does sound like Malthus. You produce more food, you have too many people, the people end up dying in misery and, well, misery and vice is Malthus' phrase. But in this case, misery, dying of plague was a pretty miserable way to die. However, there's a kind of weird turning inside out, if you think of it in Malthusian terms, because in fact, yes, you got the increased food production, you got population growth in Europe, but then a whole bunch of those Europeans migrated. The population, the movement of population from Europe to other parts of the world in the 17th, 18th, 19th centuries is an unprecedented demographic phenomenon. Just gargantuan numbers of Europeans go overseas, which leads to the misery and death of other people. That's not the Malthusian argument. It's not the peoples who were overpopulated who died. It was the peoples who weren't so overpopulated who died of these diseases, if you look at what happened when Europeans arrived in places like the Americas. This is accompanied by wholesale ecological transformations, which leads to huge increases in food production. So you can't really make sense of this as a Malthusian argument after all. How might we object to Crosby's argument? And here, what I'm doing today is simply providing you a kind of big overview of his whole argument. In subsequent lectures on Thursday and a week from Thursday, we'll look in more detail at the actual pieces of this argument. Right now, we're just trying to get our minds wrapped around the whole thing. Might we think of this as basically environmental determinism? What is environmental determinism? Anyone know? Yes? No? What would it mean to be an environmental determinist? Or to make an argument that is environmentally determinist? Anybody just want to offer a guess? Yeah?
Maybe the environment change things and not the people who change the environment?
Okay, yes. Basically, it's an argument in which you say the reason things are the way they are is the environment. The environment causes these patterns. It's to reduce some social phenomenon about humans and society to the characteristics of the environments in which they are found. Right? And really gross, simple examples of this would have it be the case that somehow the climate where you live affects your temperament. Right? The idea that in tropical climates, everyone is kind of laid back because it's just so hot. I mean, all I really want to do is sit on the beach. Right? That's the idea that people there are like that because the temperature is like that is an environmental determinist argument. Now, the reason these matter is that environmental determinism is like 3,500 years old in the Western tradition. It's been going on for a long time, and it sort of never goes away, and it fairly routinely produces some really retrograde ideas about the differences among peoples, for example. Basically, the idea that you'll never get those people on those beaches to work hard enough because it's just who they are. They are just lazy. It's the kind of thing Europeans said about people in most of the tropical world for hundreds of years. At a global scale, perhaps this is an environmentally determinist argument, right? Insofar as he's saying this package of plants and animals and humans and organisms and diseases and so forth works in certain climates. And so it went certain places and succeeded there because of the climates there, and it failed in other places because of the climates at those places, right? But it gets a lot more complicated when you start zooming in, scaling down, and looking at this at smaller scales and trying to make it work on the ground, so to speak, right? And I'll get into some of those problems here. So, for example, corn and potatoes. They went the other way. They didn't actually evolve in the Old World as part of the Old World Neolithic Revolution. They actually evolved in the Americas. They were domesticated by Native Americans. They were here, they were found by Europeans, so to speak, when the Europeans got here, and they were such magnificent food sources that they were taken back to Europe, and they became extremely important sources of food in Europe for Europeans. So wheat, which went from Europe to the New World, is not the whole story here. There's also questions about how do we explain places where Europeans did have the climate but didn't succeed in dominating, in displacing the native populations. Northern Mexico is a nice example. The Spanish threw all kinds of money and people and guns, armies, missionaries, the whole 9 yards, at the native peoples of what we now think of as northern Mexico or the southwestern United States, and never succeeded. The Apaches and others, the Seris, fought them back and prevailed over and over and over and over and over again for hundreds of years. And in some cases, they actually took those animals, for example, horses, cows, and they took some of those plants, and they said, thanks very much, these are nice. We like these. We can really work with these. And they did this sort of reverse game on the Europeans. The Great Plains is another nice example, right? The horse shows up, courtesy of the Spaniards, and the Native Americans quickly learn how to tame, break, ride, utilize horses, and turn around and use them not only to fight the Spanish and then subsequently to fight the Americans, the U.S., but also to develop new ways of making livelihoods for themselves, right? It changed their ability to hunt bison, for example, made possible vast increases in the number of bison they could kill. So it's a little harder to make this work when you start looking at specific examples of plants, animals, humans interacting, old world, new world peoples interacting at tighter geographical and temporal scales. Here's a depiction of this, sort of looking at it from the perspective of all of the domesticated plants and where they came from. So we'll look at the table in the lower right in a moment. For now, focus on this map. This is the world divided up into regions according to plant genetic diversity. And this is a way of classifying the plants of the world regionally based on patterns. These are areas where you can sort of say, okay, certain collections of plants evolved in roughly this place. And look at where you break that out. These are the crops. These are the industrial crops. Well, and actually the starred ones are industrial. This is the range of plant diversity. These are the plants that have been domesticated and become important agricultural crops. And you can see that they came from all over the world, but they didn't predominantly come from the old world, or from what we think of as the old world of the Neolithic Revolution that Crosby's considering, right? So the longest lists, first is Latin America, in terms of the diversity of plants that have turned out to be useful, suitable for domestic agricultural production, including corn and potatoes, which are, of course, hugely important in world agricultural production today. Rice, which is equally important, is the other big one, and it doesn't come from Southwest Asia. It comes from East Asia, right? You look at Australia, there's nothing there, which would fit the Crosby argument. North America, there's just one, but it's not fair to say in gross that somehow the old world is where all the good agricultural crops, plants evolved. It's simply not true. The New World was also extremely important, and other parts of Asia were extremely important. So, again, the sort of environmental determinist argument doesn't quite work when you start looking at the details. What about cultural Darwinism? Might this be seen as a way of naturalizing the domination of Europeans over non-European peoples? Right? And by that I mean providing an explanation which makes it look like it's simply a fact of nature, that somehow Europeans, it's not because they had this creepy dominating impulse that, you can't sort of blame them. It's just that they had all these germs. They couldn't help that. They showed up and all these other people died. Well, that's just nature, right? Is this that kind of argument? And this is where, I don't know if we're going to be able to get through all of these. We have to start thinking about what it would mean to make a cultural Darwinist argument. Here, we're going to run through a variety of ways of what evolution is, how evolution happens, and ask ourselves whether it's even relevant to try to apply it to culture. So before we can apply it to culture, we have to have some idea what we're actually applying. here's a nice depiction, or a simple sort of conceptual diagram depicting evolution by natural selection. And what we're imagining here, starting in the upper left, is that there's some organism. It could be a plant, it can be an animal, it can be a germ, and it's in some environment, and they are interacting with each other. Over time, this is the arrow going to the right, organisms mutate. Right? Everyone knows what that means? Right? Right? Okay. As long as everyone's comfortable with that term. What that means is that over time we're going to have multiple organisms, or rather a variety of organisms, a variety of mutations at least, of that organism. Right? There are a variety of possibilities that will arise simply by the nature of genetics. Over time, these mutations are going to come into some kind of competition with each other. And that competition is going to be mediated precisely by that relationship with the environment, right? It's not that these organisms fight it out in hand-to-hand combat with each other. It's that they're each trying to reproduce in their environment. The environment is also not static, right? The environment can change as well. And it's a question of which mutations find greater success in reproducing themselves within that dynamic environment over time. And so the result, according to sort of standard Darwinian theory, eventually you end up with a new organism interacting with an environment which, and this goes on and on and on and on and on over vast stretches of time, and produces the diversity of life that we know. Now, this links back to that idea of divergent evolution and mammals and so forth. It applies to plants, it applies to germs, so on and so forth. Now, contrast that, try to make that work with cultures instead of organisms. Right? To make a cultural Darwinist argument, you would have to basically postulate that there is a culture living in an interaction with its environment and that it somehow mutates over time. Then there is competition among different cultures, and then as a result of that competition and those mutations, and remember, it's kind of interesting to wonder what it would mean, you know, is mutation really a concept that applies to a culture? I mean, sure, cultures change, but do they change in the same way via genetic mutation, for example? I mean, how analogous is that? But it results in some kind of new culture interacting with its environment. That would be the basic bones of a cultural Darwinist argument. Now I want to contrast this. I mean, I'll come back to whether that makes any sense in a moment. To evolution by artificial selection. And the reason this matters is that this is actually a key part of the Neolithic Revolution. It's the shift from evolution by natural selection to evolution by artificial selection that essentially describes, differentiates domesticated agriculture, plants and animals, from non-domesticated wild plants and animals, right? So here we have the same basic pieces except one difference. The environment is modified by humans, consciously or unconsciously, but we're specifically interested, I mean, how conscious it was at different points in time is open to speculation, but for now let's just say the environment is modified by humans. And an example of this, a key example of this, is controlled breeding. Now, what does that actually entail? Anybody know? With plants, for example, what does that entail? How do we control the breeding of plants? Well, okay, maybe it's easier to start with animals. How do we control the breeding of animals? None of you have ever done this? Yeah.
You only have the ones you want to mate.
Bingo! Okay, you only put the ones you want to mate together and let them mate. It's not that complicated. So you choose, you pick, you decide, I like this one and I like that one, and we're going to mate them because we like them more than we like the others. And we want the next generation of horses, cows, cats, dogs, you name it, to be like these rather than these others. How about with plants? Yeah. Okay. You only pollinate the ones you want to pollinate, or more generally, yeah? You can separate them. You only replant the ones that did well in the preceding generation, right? So you grow a field of corn. You don't eat all of the corn, do you? No, you save some of that corn to provide seed for next year when you are going to plant corn again. And which seed do you save? You save the seed from the plants that did the best. Now, what best means is obviously open to a lot of debate, right? Best can mean the nicest color, the biggest stalks, whatever, you know. Or it can mean it did really well even though it didn't get very much rain. But it's a question of the humans stepping in and saying, we're going to replant these fruits, these seeds, from this particular plant, and we're not going to replant these others. We're going to eat those. Or we're simply going to throw them away. But we're not going to replant them. And over time, what that means is that this interaction, we are essentially capturing the mutations that we prefer and propagating them to the, well, preferentially, and therefore to the detriment of the other mutations. This is what artificial selection is. And over time, that means we not only get new organisms, which we would get by natural selection anyway, we get very different new organisms that have been selected over time to fulfill the needs, desires, expectations, whatever, criteria of human preference. This is how we got things like wheat, corn, cows, horses, that kind of thing. So could we think of cultural evolution as not a matter of natural selection, but of artificial selection? This would seem to make more sense. In other words, the cultures and their mutations are not interacting with a randomly changing wild environment, but in fact with a humanly modified and in some ways humanly created, produced environment. These cultures are not only competing, but in many ways cooperating with each other. And over time we get a new culture not by natural selection, but by artificial selection. This looks a whole lot more, well-suited to Crosby's argument. If we want to try to call him a cultural Darwinist, if we want to sort of go down that path and ask ourselves, is this cultural Darwinism? It's much more likely that this is what he's talking about, given the nature of his argument and given the ways in which humans interact with organisms. It's much more likely that this is about artificial selection, or it's a better analogy than natural selection, which actually takes the wind out of the sails in a lot of ways of cultural Darwinism, or at least it doesn't naturalize it in the same way. It doesn't say, oh, this is just the result of nature. So, some questions. First, we need to ask, are cultures analogous to organisms at all? What would it mean? What does it mean to say that a culture mutates, for example? Like this is an analogy or a metaphor, but is it a coherent one? In many ways, I would suggest it's not. Is cultural evolution natural, artificial, both, or neither? This distinction between natural and artificial selection is critical for understanding the domestication of plants and animals and the evolution of domesticated plants and animals. But it's not clear whether or how it applies to cultures. Are all human modifications of the environment the same or not? I mean, to say that cultures somehow result from artificial selection then leads to questions about, okay, what does it mean for humans to modify the environment? Is it the same thing to pick and choose which corn to replant as it is to, well, sail across the ocean and infect another people with a disease that they are not resistant to? Are all environmental determinations of humans the same or not? Are there any questions? There's also the problem of tautology, and I think I'd probably better just pick that one up next time. So we will see you on Thursday. Thank you.